Welcome, my dear student, in our math program for Secondary 3. Dear student, today we are taking new title, its lesson differentiation. What do you meaning of the differentiation? Dear student, the last lesson we were learning continuity of the function. Today we are taking differentiability of the function. Dear student, look at the differentiation. Differentiation, if y equals f of x, then dy over dx equals what? F dash of x equals limit when h tends to 0, f of x plus h minus f of x over h. dy by dx means differentiation of the function y equals fx. When we find dy by dx, we find limit when h tends to 0, f of x plus h minus f of x over h. Remark, y equal f of x is differentiability at the point x equal a if dy over dx at x equals a is exist. This condition is very important, dear student. Y equal f of x. This function is differentiability at the point x equal a when dy over dx at x equal a exists. Right hand side and left hand side. Remember, what is the exist function? Right hand side, right hand derivative, left hand derivative. Means f of a positive equal f of a negative. Look at the graph. The line represent a belongs to f dash x. When we find f dash a positive and f dash of a negative, we find f of dash a positive equal f dash of a negative equals limit when x tends to a f of x. This means this function is differentiability at x equals a. Right hand derivative means f dash a positive equals limit when h tends to a positive f of a plus h minus f of a over h. Left hand derivative means f dash a negative. What do you mean? Limit when h tends to a negative f of a plus h minus f of a over h. If f dash a positive equals f dash a negative, then f of x is differentiability at x equals a. F dash a positive not equals f dash a negative, therefore f of x is not derivative at x equals a. F of x is differentiable at x equals a, then f of x is continuous at x equal a. Remember, dear student, f of x is differentiable at x equals a when f of x is continuous. Then any function is differentiable must be continuous at this point, x equals a. Remarks, converse of the theorem is false. F of x is continuous at x equals a, then f of x is not differentiability at x equals a. But we can, f of x is continuous, we can must prove f of x is differentiability or f of x is not differentiability. The condition of f of x differentiation at x equals a, function is continuous at x equal a and exists at x equal a. But f of x is continuous at x equal a, maybe f of x is differentiable or not differentiable. f of x is differentiation, then it is constant. But f of x is continuous, may be a differentiation or not differentiation. Remember, dear student, f of x is differentiability at point x equal a, then the function is continuous at point x equals a. F of x is continuous, may be differentiability at x equal a or not differentiability at x equals a. The must be proves that f of x is differentiability must be f of x is continuous. But f of x is continuous, maybe this function is differentiability or not differentiability. F of x is not continuous, then we deduce f of x is not differentiability at x equals a. Dear student, this theorem is very important. What do you mean f of x is differentiability at x equals a? In this case, we must prove f of x is continuous at x equal a. When f of x is differentiability at x equal a, therefore we deduce that f of x continues at x equals a. But when f of x is continuous at this point, maybe function is differentiability or differentiability at x equals a. Dear student, look at the important example. This example is very important. Discuss the differentiability of f of x equals function f of x has two branches. The first branch 3x minus 2 when x more than or equal to x2 plus 3 when x smaller than 2. Remember, dear student, now we discuss the differentiability of function f of x equals 3x minus 2 when what is the condition in this? What is the domain? X more than or equals to x2 plus 3 when x smaller than 2. Solution. F of 2, 3 times 2 by substitution about x equals to 3 times 2 negative 2 equals 4, the first branch. Therefore, f of 2 positive equal limit when x tends to positive, right at 2, 3x minus 2 equals also 4. F of 2 negative, limit x tends to 2 negative, we substitution about the second branch x2 plus 3. Therefore, answer is 4 plus 3 equals 7. Dear student, look at f of 2 exists equals 4. But in this case, f of 2 not equals f of negative 2. Why? Because f of 2 positive equals 4. F of 2 negative equals 7. What you deduce, dear student? F of 2 positive not equals f of 2 negative. Therefore, f of x is not continuous at x equals 2. What you deduce? F of x is not differentiability at x equals 2. Dear student, when we prove that the function is differentiability at x equal 2, the first we prove that f of x is continuous or not continuous. This function is not continuous at x equal 2, then f of x is not differentiability at x equals 2. Another example. Discuss the differentiability of f of x where f of x equals 4x minus 1 when x more than 1, x power 2 plus 2x when x smaller than or equals 2 at x equals 1. Remember, dear student, 4x in this case, f of x 4x minus 1 when x more than 1, x2 plus 2x when x smaller than or equals 1. What discuss of the function at point x equals 1? Solution. F of 1 equals 1 power 2 plus 2 times 1 equals what? Equal 3. F of 1 negative, limit when x tends to 1 negative, equal x power 2 plus 2x, substitution about x equals 1, therefore equal 3. F of 1 positive, limit when x tends to 1 positive, equals 4 times what? 4 times 1 minus 1 equal 3. What you deduce, dear student, this function is continuous at x equals 1. Why? Because f of 1 negative equal f of 1 positive equal f of 1 equal 3. We deduce that limit when x tends to 1, f of x equal 3. Limit when x tends to 1, f of x equal f of 1. F of x is continuous at x equals 1. Dear student, look at f dash of 1 positive. Limit when h tends to 0 positive, f of 1 plus h minus f of 1 over h. Limit equal 4 times 1 plus h minus 3 minus 1 over h when h tends to 0. Therefore, limit equals 4 plus 4h minus 1 minus 3 over h. Limit h tends to 0 positive, 4h over h equals what? Equals 4. F dash 1 negative. Limit when h tends to 0 negative, f of 1 plus h minus f of 1 over h equals 1 plus h for all power 2 plus 2 multiply 1 plus h minus 3 over h equals limit h tend to 0 negative 1 plus 2h plus h power 2 plus 2 plus 2h minus 3 over h. We simplify or we add the like terms, 2h plus 2h for h, 1 plus 2, 3 minus 3, 0. The answer is limit when h tend to 0 negative 4h plus h power 2 over h. What you do, dear student? We take h common factor equals 4 when h tend to 0. Then f dash of 1 positive equal f dash of 1 negative equals 4. Therefore, f of x is differentiability at x equals 1. Another example. Discuss differentiability at x equal 1, x equal negative 2, x equal 3 for the function f of x equals x power 2 plus x plus 1 when x more than or equal negative 2 smaller than 1, 3x when x more than or equal 1 smaller than and equal 3. Remember, dear student, we now discuss the differentiability at x equals 1, x equal negative 2, x equal 3. Remember, f of x function has two branches, x2 plus x plus 1, when the domain in this case more than or equals negative 2 smaller than 1 and equal 3x when x more than or equal 1 smaller than or equal 3. Look at the solution. We have 3 points, negative 2, 1, 3. Interval from negative 2, 1, f of x equal x2 plus x plus 1. From 1 to 3, the function is 3x. When f of x equal negative 2, the function equal 3. F of x at x equal 1, the function equal 3. F of x at x equal 3, function equals 9. At x equal 1, f of 1 equals 3. F of 1 positive, we substitution about 3x. 3 times 1 equals 3. When we find f of 1 negative, we substitution about function equal x power 2 plus x plus 1. By substitution about x equals 1 in x power 2 plus x plus 1 also equal 3. Therefore, limit f of x equal 3. The function is continuous at x equals 1. F of 1 equal f of x. F of x is continuous at x equals 1. Now we discuss f dash of 1 positive. F dash of 1 positive, we find limit h tend to 0 positive, f of 1 plus h minus f of 1 over h equals limit h tend to 0 positive equal 3 plus 1 plus h minus 3 over h by substitution and simplify. 3 plus 3h minus 3 over h equals 3h over h equal what? Equal 3. 3h over h equal 3. F dash 1 negative, we substitution about x power 2 plus x plus 1. We find the limit h tend to 0 negative f of 1 plus h minus f of 1 over h in function x power 2 plus x plus 1. Look at 1. We substitution about x equals 1 plus h. Substitution about x. Then limit h tend to 0 negative. 1 plus h for all power 2 plus 1 plus h plus 1 minus 3 over h. By using simplify, dear student, we find one limit when h tend to 0 negative 1 plus 2h plus h2 plus 1 plus h plus 1 minus 3 over h. We look at the 1 plus 1 plus 1, 3 minus 3 equals 0. The limit becomes limit h tend to 0 negative 3h plus h power 2 over h. We find h highest common denominator. Therefore, limit h x tend to 0, 3 plus h equal 3. Therefore, f of f dash 1 positive equal f dash of 1 negative. Therefore, f of x is differentiability at x equals 1. Now, we are translate, dear student, at x equals negative 2. The function is undefined when x smaller than 2. Therefore, we will discuss the right hand derivative only. F dash of negative 2 equals f dash of negative 2 positive limit f dash or limit h tend to 0 f of negative 2 plus h minus f of negative 2 over h equals limit h tend to 0 positive negative 2 plus h for all power 2 minus 2 plus h plus 1 minus 3 over h becomes limit h tend to 0 4 negative 4h plus h power 2 minus 2 plus h plus 1 negative 3 over h. We simplify, the limit becomes negative 3h plus h power 2 over h by using h highest common factor, and we use simplify, the function becomes limit h tend to 0 positive equals negative 3 plus h equal negative 3. F of x is differentiability at x equal negative 3, x equal negative 2 from right hand side. At x equal 3, look at, dear student, the function is undefined when x more than 3. Therefore, we will discuss the left hand derivative only at x equal 3 negative. F dash of 3 positive, f dash equal 3 negative. Look at f dash of 3 positive equal f dash of 3 negative. Limit h tend to 0 negative f of 3 plus h minus f of 3 over h equals what? Limit h tend to 0 negative 3 multiply 3 plus h minus 9 over h. Limit h tend to 0 9 plus 3h negative 9 over h. We simplify 9 negative 9 equals 0 becomes 3h over h equal 3. Therefore, dear student, f of x is differentiability at x equals 1 from left hand side. Now we are translate another example. F of x equals 2x plus 1 when x smaller than or equals 1, x power 2 plus a when x more than 1. If f of x is continuous at x equal 3, find the value of a. Dear student, now we are translate to another example. It's very important. This function is continuous at point x equals a or x equals 1. We find the constant a. In this case, dear student, function is continuous. What do you mean of the function of continuous? We mean f of 1 positive equal f of 1 negative. About substitution about f of 1 positive equal f of 1 negative to find the value of a. This example is very important. Look at the solution. Discuss the differentiability if f of x at x equals 1. Look at the solution. F of x is continuous. What do you mean of the continuous at x equals 1? Excellent student. F of 1 positive if equals f of 1 negative. The function is continuous. What is the condition of continuous? The function at x equals a. The condition is f of a1 positive equals f of 1 negative. Now we are find f of 1 positive 1 plus a, f of 1 negative 2 plus 1. What the value of a, dear student? A equals 2. When f of x is continuous, f of 1 positive equal f of 1 negative. In this case, f of 1 positive equals 1 plus a, f of 1 negative 2 plus 1. What is the value of a? We find the value of a equals 2. After that, f of x becomes 2x plus 1 when x is smaller than or equals 1, and x2 plus 2 when x more than 1. The value of a becomes 2. Therefore, dear student, for the differentiability, f of 1, f dash 1 positive equals what? Limit when h tend to 0 positive, f of 1 plus h minus f of 1 over h. In this case, what you substitution about x in the first branch or second branch? Second branch. Why? Because x smaller than or equal or more than 1. More than 1. F dash of 1 positive, remember, we substitution about second branch, x power 2 plus 2. Why? Because in this case the domain x more than 1. And we find f dash 1 positive. F dash of 1 positive becomes limit h tends to 0 positive, 1 plus h for all power 2 plus 2 minus 3 over h. By using simplify 1 plus 2h plus h power 2 plus 2 minus 3 over h. Therefore, 1 plus 2, 3 minus 3 equals 0. Limit becomes limit h tend to 0 positive, 2 plus 2h. What you mean of the limit equals 2? H tend to 0, limit equals 2. Therefore, function or f dash 1 positive equals 2. F dash 1 negative, limit when h tends to 0 negative. F of 1 plus h minus f of 1 over h. After that, we find the limit h tends to 0 negative by substitution the first branch 2 times 1 plus h plus 1 minus 3 over h. We multiply 2 times 1, 2 plus 2h plus 1 minus 3 over h. We simplify 2 plus 1, 3 minus 3. It becomes 2h over h equals 2. Therefore, the function f of 1 equal f of 1 negative, f dash of 1 equal f dash of 1 negative. Therefore, f of x is differentiability at x equals 1. Another solution. Find the value of a and b if f of x, ax power 2 plus bx plus 7 when x smaller than or equal to, f of x equals 5 over x minus 1 when x more than 2. Find the value. What is the condition of this function? Look at the solution. F of x differentiability at x equal to, f of x is continuous also at x equal to. When f of x is, dear student, when f of x is differentiability at x equal to, what you deduce? F of x is continuous. Why? Because any function is differentiability at x equal to, this function is continuous at x equals 2. What you deduce, dear student? F of 2 positive equal f of 2 negative. What is the condition of the continuous at x equals 2? F of 2 positive f equals f of 2 negative. What you mean f of 2 positive? Was substitution about x equals to 5 over x minus 1 equals 4a plus 2b plus 7, f of 2 negative. In this case, dear student, 4a plus 2b plus 7 equals 5. Therefore, 4a plus 2b equals negative 2 divisible by 2. 2a plus b equals negative 1, this first equation. F of x is differentiability at x equals 2. Also, we find f dash of 2 positive equal f dash of 2 negative. 5 over 2 minus 1 equal 2a times 2 plus b. Therefore, for a plus b equals negative 5. In this case, we use omitting method or substitution method from third prep. We have two functions, for a plus b negative 5, negative a plus b equals negative 1. By using omitting method, subtract second from the first. Therefore, 3a equals negative 4. Therefore, a equals negative 2. 2a equals negative 4. The first equation, 3a plus b, 3a plus b equals negative 5, negative a plus b equals negative 1, 2a equals negative 4, a equals negative 2, 4a plus b equals negative 5, substitution about a equals 2, negative 8 plus b equals negative 5, therefore b equals negative 5 plus 8 equals what? Equals 3. Remark, dear student, f of x equals 5 over x minus 1, f dash x equals what? In this case, when we find f of x equals 5 over x minus 1, therefore differentiation of this function, denominator power 2, denominator times derivative of the numerator minus numerator times derivative of the denominator, f of dash of x equals x minus 1 times 0 minus 5 times 1 over x minus 1 for all power 2. The function is f dash of x, in this case negative 5 over x minus 1 for all power 2. Another example. Discuss the differentiability of f of x equals sine x when x smaller than or equal pi over 2, 1 plus cosine x when x more than pi over 2 at x equals pi over 2. This function is very important. Look at the solution. f of pi over 2, we find sine of pi over 2. What you mean of pi over 2? 90. What you mean of sine 90 equals 1. Therefore, f of 90 equals 1 exists. What is the value of f of pi over 2 positive? Dear student, limit when x tends to pi over 2 positive equal 1 plus cosine x about cosine 90 equals 0, 1 plus 0 equals 1. f of pi over 2 negative equals limit x of tends to negative pi over 2 negative sine x sine pi over 2 equals 1. In this case, we find limit x f of x when x tends to pi over 2 equals 1. f of pi over 2 equals 1. Therefore, the function is continuous. What you mean is continuous at x equals 1? f dash of pi over 2 negative equals sine limit when h tends to 0 sine pi over 2 plus h minus sine over 2 over h. Remember, limit h tends to 0 sine power 2 sine over power 2 sine pi over 2 plus h equal cosine h. From the first second, sine 90 plus h equal cosine x. Cosine h minus sine over 2 equal h over h. Therefore, limit cosine h minus 1 over h when h tends to 0. Cosine 0 equal 1 minus 2 sine power 2 h over 2 minus 1 over h. Look at, dear student, cosine h equals, in this case, we substitution about cosine h equal 1 minus 2 sine power 2 h over 2 from the first secondary. Therefore, limit equals substitution negative 2 sine power 2 h over 2 over h when h tends to 0. Therefore, equals negative 2 limit h tends to 0 sine h over 2 over h equals times limit when h 10 to 0 sine h over 2, therefore equals negative 2 times half times 0 equals 0. What you deduce? F dash of pi over 2 positive equal limit h 10 to 0 1 plus cosine h over 2 minus h minus 1 over h. We simplify 1 negative 1, therefore limit h 10 to 0 negative sine h over h equals 1 negative 1 by using theorem. Therefore limit f dash pi over 2 positive not equal f dash pi over 2 negative, therefore f of x is not differentiability at x equals pi over 2. Dear student, remember math simple, work, think, produce. I am hope to meet again. Goodbye.